nuclear fission and as well as the nuclear fission process to be held in according to chain reaction. According to the chain reaction and a nuclear reactor, we discussed how the nuclear reactor works and what are the main components in the nuclear reactor. What is the function of that nuclear reactor? Works on a principle or base of a controlled chain reaction. So, about the chain reaction, when a heavy mass of a nuclei disintegrates, means when a heavy mass splits into the two nearly equal or more nucleus and emits 3 neutrons and with energy, then that will be the process is called nuclear fission. Means when heavy mass of a nuclei try to be stable the small mass of a nucleus. Small mass of a nucleus are having the very stable than the heavy mass of a nucleus. So that's why heavy mass of a nucleus splits into the two small nucleus. So that here we can consider that when a heavy mass of nucleus is splits into the small mass of a nuclei, so that the small mass of nucleus comes to its stable. In case of nuclear fission process, the elements which is released in that splits the smaller mass of nucleus are radioactive materials, which is harmful to the atmosphere and as well as for everything. So the next topic we are going to discuss about nuclear fusion. What is meant by the nuclear fusion? Means fission means the splits, heavy mass of a nucleus splits into the two another nucleus. Here the fusion means, fusion is nothing but combining. Fusion means combining. When a small mass of a nucleus combined to form a stable heavy mass of a nuclei is called fusion. Here the process of formation of a single stable nucleus. The process of formation of single stable nucleus by fusing or combining two or more lighter nuclei. Means whenever we taking the small mass of nucleus by combining both total 2 or more nucleus and to form a heavy mass of a nuclei, then that is called means when a small mass of nucleus combining together and it is formed the stable heavy mass of a nucleus is called nuclear fusion. In that case of nuclear fusion, the energy which is released in the process of fusion is called as a fusion energy. So that let us see one example, the formation of helium atom means when a small mass of nucleus, here we are taking the hydrogen nucleus, 4 hydrogen nucleus combined and formed a helium nucleus. And if we compare that, the nucleus atomic mass, here the nucleus is having the mass less than the whenever the 4 protons are combined. So that here is also one of the positron is emitted and as well as some of the energy is 25.71 mega electron volts energy is released during this process. Means and the formation of helium nucleus by fusion of 4 hydrogen nuclei and releasing 25.71 mega electron volts energy. So that we can say that the fusion energy per nucleon is about, means the fusion energy, whenever the fusion process, in the fusion process the energy which is released is 7 times more than the energy released in the fission process. Means when the nucleus splits into the small mass of a nucleus, the energy released is less than the whenever the small mass of a nucleus combined to form a heavy stable nucleus is more. So the fusion energy per nucleon is about 7 times more than the fission energy. This is about the definition about nuclear fusion. If we compare the fission and fusion, then what is the differences between the fission and fusion, or what is the comparisons between the fission and fusion? Once again I am telling you, nuclear fusion means when small mass of a nucleus combine and to form the stable heavy mass of a nucleus is fusion. And fission means when a heavy mass of a nucleus splits up into the 2 or more fragments, that is called nuclear fission. So what is there? Let us see the comparison between the nuclear fission and fusion. What are the basic comparisons and what is the differences between the both? Let us see comparison of nuclear fission and fusion. What are the basic? Means first of all we should know that what is fission and fusion. The definitions are: When a heavy mass of a nucleus like radioactive elements uranium splits up into two or more whenever they bombarded with the slow moving neutron, whenever the uranium 235 radioactive substance is bombarded with a slow moving neutron, considerable release amount of energy is released. Means either 216 mega electron volts of energy will be released. So here the when a heavy mass of nuclei 235 uranium 235 splits up into the two nearly equal parts by the bombardment of slow moving neutrons, considerable released amount of energy is released. Means here whenever the uranium atom splits up into the several fragments, then some of the energy is released, so that is called as a fission process. In that fission process we can see that for fission means whenever the one uranium atom is splits and it emits the neutrons, only in that only single fission 200 mega electron volts energy is released for fission process. But whenever the energy released per nucleon is very less, energy released per nucleon is less if we compared with the fusion process. Here the fusion means when two lighter atoms like hydrogen or protons are fused means combined into heavier atom, then helium and a large amount of energy is released. When a large amount 25.71 amount of energy, 25.71 mega electron volts of energy is released. So that here this is the amount of energy which is released per not only for the nucleon, is for the only for the single fusion. So that the amount of energy released per the nucleon is very more than the amount of energy which is released in the fission process. So that energy is released per nucleon is more, and in the fission process the energy which is released per nucleon is less. And in this case of fission process, the particles which are involved is neutrons. Due to the neutrons, here the fission process will be held. In that case of protons is the positive charged particle which can be ionized more, so that's we can ionize the more atmosphere. So that's why here particles are involved are more in our proton, so that's why the energy which is released more. Here fusion takes place, means fission takes place at the room temperature and pressure, and if we compare with the fusion does not take at the room temperature and pressure, because of here fusion takes place only very high temperatures and very high pressures, then only the fusion process can be done. Here the fusion produces the radioactive elements, means whenever the uranium atom uranium 235 here uranium 235 splits up into this, then barium and krypton are released, which is the radioactive elements which is harmful for the harmful radioactive elements. So that's why here in this case of fission process the radioactive elements are produced, barium, krypton, which are harmful in the fission process. In case of fusion process, in the fusion process the products which are fusion is harmless. So these are the non-radioactive elements. This is the comparison between the fission and fusion. Once again, whenever the nucleus are splits up into the two or more fragments, energy is released, it is called fission. When the small mass of a nucleus combine and form a heavy mass of nucleus is called fusion. And in the fission process 200 mega electron volts energy released per fission. In this case of 25.71 mega electron volts energy per released per fusion. In that case of the energy is released per nucleon is less. In this case of fusion the energy released is more, per nucleon is more. Particles involved are neutrons in fission. In fusion particles involved are protons. Fission takes place at room temperature, fusion takes place in high temperatures and high pressures only. In the fission process the elements which is produced by the source is harmful, but in case of fusion process the fragments which is involved, means whenever the products which is released in the fusion process are not harmful, those are harmless than non-radioactive elements which is produced in the fusion process. In this case the one thing is in the fission, for example, in the fission process example is atom bomb. In the fission process the example is atom bomb. In the fusion process can be done, example is hydrogen bomb. energy is released more in the hydrogen bomb than the atom bomb. So, this is about a comparison of nuclear fission and fusion and about the nuclear fusion. Next, what are the operations, means like stellar energy, whenever the some energy is released from the sun, the energy, what is the process is going on in the sun to produce the continuous energy radiation. So, that is called as stellar energy. The operation which is held in the sun is called stellar energy. Then why the stars are sparkling, why the radiation is producing in the sun and stars is called stellar energy.